Okay. Das sollte theoretisch funktionieren. Sollte ist die große Annahme hier. Muss man. Ne, das wird schnell. Öffnen wir zweimal Fokus. Das ist so richtig. Das wollen wir so haben. Und das schmeißen wir damit runter. Ah, hey, ja. Scheint zu funktionieren. Ist auch. Okay, ja, Audio ist auch im Stream. Add everyone streaming. Yep. Funktioniert wie ich will. Upsala. Mal loader schedule process. Okay. Gibt ein paar Sachen jetzt. Und zwar muss ich erstmal dafür sorgen, dass ich einen Prozess starten kann. Wieso ist das hier definiert? Keine Ahnung. Process, Code, keine Ahnung, was das ist. Ich hatte halt einige Sachen halt einfach kopiert von anderen Dings. Start Process, Void Start Function Pointer und attached, keine Ahnung. Ja, das wäre das eigentlich. Stimmt, ich werde auch eine Process List haben wollen. Würde ich die einfach als Array machen? Oder einfach als Pointer zu einem Array? Theoretisch würde ich das nicht machen wollen. Theoretisch würde ich eine Linked List haben wollen. Die Sache ist Linked. Nee. Hatte ich hier nicht schon irgendwo eine Linked List mit drin? Keyboard. Ah, stimmt, das war der Circular Buffer. Keyboard H. Ich kann den einfach nicht so kopieren. Es sollte keine Name Collisions geben. So, ich mach's einfach mal so. Sicher. Das zu das. Dann Circular Buffer Length. Nein. Das wäre hier. Machen wir das einfach so. Define Max Processes als was bei 16 oder immer Max Processes, dann Head ist ein Processor, ja. Das müssen wir hier unten haben. Tail ist auch ein Process. Warte. Hallo, wie programmiert man einen Scheduler? Erste Frage, weißt du, was ein Scheduler ist? Wenn du das weißt, ich kann dir ein Beispiel zeigen, was ich von dem ich hier lerne. Das ist Interrupt Handler. Also, wenn du weißt, wie Interrupts funktionieren, dann sollte es okay sein. Also hier haben wir einen Interrupt für einen Timer. Das ist einfach der normale Pit-Interrupt, glaube ich. Ich weiß nicht. Ah ja. Und was wir hier machen ist, hier wird einfach der Stack-Pointer auf den Stack gepusht, was Sinn macht. Wir hören uns den Kernel-Kontext. Das hier, das erste ist erstmal nicht so wichtig. Man könnte das hier raus kommentieren, würde funktionieren. Wir wollen trotzdem immer noch einen Stack-Pointer pushen, da das der alte Prozess ist. Und dann wollen wir switchen. Was wir machen hier einfach ist, wir tun, das kann ich einfach mal hier, Switch Kontext ist hier definiert. Und EAX ist der Return-Wert. EAX ist Return-Wert, das ist normaler Linux ABI oder nicht. Wenn man es ganz richtig will, ist das System 5 AMD 64 ABI. Lass mich das verifizieren. System 5 AMD 64 ABI. Oder ja, anscheinend einfach. Das reicht auch aus anscheinend. Lass mich sehen. Das wird gleich weiß. Und Windows ist Return-Wert auch in EAX. Okay. Bei Windows kenne ich mich da nicht so aus. Okay, die Seite will gerade nicht laden. Ah ja. Und was wir hier machen theoretisch ist, wir tun den Prozess anmappen und halt dann hier deaktivieren. Ich verstehe das hier nicht ganz genau. Das ist ein ist lange her. Mit Standard Call, glaube ich. Die Sache ist, weißt du, was Standard Call ist? Standard Call heißt einfach nur eine Funktion. Ich habe mal in die Win API reingeschaut. Windows API Standard Call. Steht hier da, wie es definiert ist? Ah ja, nee, steht hier nicht da. Es ist Real Hobby. Calling Convention, ja. Es ist so komisch, wenn man sich den Code eigentlich anschaut. Ist Standard Call. Ah ne, ist Win API ist Standard Call definiert. Ja. Es ist sehr verwirrend. Aber es wird theoretisch einfach nur der Stack Pointer ausgetauscht. Der alte Stack Pointer wird gesaved im Prozess und dann wird ein neuer Stack Pointer einfach reingesetzt, der wird returned. Dann schmeißen wir den hierher, sagen der CPU, ja, wir haben den Interrupt acknowledged und dann poppen wir alle Registers vom Stack und weil wir gerade eben den Stack Pointer ausgetauscht haben, heißt das, wir haben jetzt den Stack vom anderen Prozess und alle halt Registers vom anderen Prozess und dann halt einfach ein Interrupt Return. Und was ich jetzt machen will, ist zumindest den Kontext-Switch leicht hinbekommen. Hast du das ausgeschrieben? Nein, das hier ist nicht meins. Das hier ist, ich kann es einfach zeigen, GitHub Thermopillars. Da. Das ist von einem Kerl geschrieben, der hat an der Uni gelehrt. Und das hat er damals in 2008 geschrieben anscheinend. Und ja, es ist sehr gut zum Lernen, weil das ist sehr minimal, das Ding. Und ja. Und ich schaue es mir halt gerade die ganze Zeit an, immer mit dazu. Was ich habe, ist das Ding hier drüben. Also, das hier, das. Und hier ist meins, wo noch nicht viel ist. Ich bin gerade dabei, wie ich alles definieren will, aber ich glaube, ich werde einfach alles einfach irgendwie, weil einfach nicht einfach sagen, okay, so ist es jetzt und dann fertig ist. Aber ja, das Problem ist jetzt mit Start Process. Wie hat der... Stimmt, wir wollen eine neue Process-ID. 64 Start. Process void function pointer 64. Okay, alle Nachrichten zurückgezogen. Okay. Next bit plus 1. Okay. Well, yeah. I also saw you be sorry I was talking so much English, German there. If the person went, then I'm just gonna be talking in English now. I'm just gonna increment the process ID. I'm gonna make a new process. New process, I gotta check, keyboard, how, it's, okay, just do with this, like with the dots, okay. There. But yeah, with also the circular buffer, I should then probably do like a process table or something. I'll figure it out. So here dot head equal yeah. That's gonna be interesting. No, wait, that's not head. Stack equal. What did I define here? Null. Wait, with commas, okay, not with semicolons. Dot heap equal null, because I need to still malloc those. And just dot rsp, that's the stack point, that's gonna be null. And then parent bit is I can just I don't need that right now if the process start by another process which I want to return to. That is not important right now. It's gonna be important if like make a terminal or something. Which is not in the scope today. Okay. Right, I'm gonna have start process just returns an integer, but yeah. So same as this, it's just this is 32-bit code. Heap and stack, we allocate some memory for that. Memories here. Right, loader, I do heap in it, okay. So with that, my heap pointer should be 64-bit aligned. So I should be able to then just, let me... new process dot stack equal malloc. Wait, that is, so I would just want to do this because this mallocs in bytes, and I would theoretically just want to have the same size as the other stacks. I can just check loader. Loader. What is that in hex? Decimal. OX 4000 to decimal. Oh yeah, nice. That's exactly that. Then I just gotta make sure that I just wanna make sure again that this is correct. So we align the heap pointer, but it's, yeah, just to be sure, we align the heap pointer. That is gonna be the current then. Then plus size is gonna be next. Then I can just return like this and just do this. Yeah. That should work. Let's see, config, what did I define for run command again? No, build command. Right. Did I not make a build command? I know. Yeah, because that's run. Okay, oh right, because it's on the laptop. Right, so build command. It's just gonna be this. build working directories, also this, and key binding. But we give it a shift F5. Okay. Right, config global build panel width 100. Stays in one place. If false, the bit panel will flip to the inactive pane. Okay. Okay. But why is it? Oh, because it was scrolled. Ah, interesting. I can just do that. What was it? Okay. What errors do we have? Huh? Whatever. Expect. Process H. Oh yeah. Yeah. Huh? Process C. Process list. Just get rid of that. Okay. Maybe. Oh. Standard and if I use define I didn't get new process stack. Include naive memory.h mem h. Right, malloc is defined. Okay, process h. What was right? These are just void pointers anyway. Because yeah, but what else would there be besides void pointers? That makes sense. Oh, it just builds. Awesome. New process dot heap equal. Do I do I need? Huh? I don't need memory for the heap, do I? Because it would it would allocate its own heap. But, I don't fucking know. I'm just gonna leave the heap now. That's fine by me. It is totally fine by me. Let's setting a process. And then maxing a context. Oh, that's just a function definition. Right. because let's see where is start process this. I need that first. Process code init. That's just an endless function, and then shell. Where is shell defined? Oh. Oh, it's because this is space here. Okay. Oh yeah, so shell is also just a function, and like process code as I... How is process code? Find again. I do not see where process code is defined. Oh, right here. Like, wait, is it? Wait, what? So type defs in int as pointer process code with argvxc. I don't know. Wait, aren't also argv and argc flipped? Isn't argv the Java and argc is our argument count? Is that hi bro? Hello. I'm currently trying to figure out how to work this. Well, I am doing fine. Yeah. Start process. Why? It just... That's the function. By the way, how are you doing? That's the function. That's switch terminal. That's the priority. It is attached, and no arguments and no argv. Okay. Hey. Oh, hello. I just visited you to know how you are. That's all. Okay. Hello, Dragon Dove. Hello. Nice to see you again. Okay. What did I want to do? Okay, I do not care about the process table. I don't care about switch context right now. Start process. Right. And the new context. Why is the instruction pointer the exit function? That's what I don't understand. Why is that the exit function? Process C, I can... Yeah, okay, I can have that here and that here. Can I flip the buffers? No. Or swap? Upsala. Swap. No. Okay. No, I started blendering and I'm going to make a model of Majima. Nice. Hope we can have fun. By the way, is the... I'm seeing, for some reason it's saying the stream bitrate is really low, even though it should be at like 6,000 kilobits, but it's saying it's like at 1/4 of that. I do not know why. Well, who knows? Okay, let me figure this out again. So we have an instruction pointer that points to the exit syscall for some reason. But then, yeah, because we check for IP here, that instruction pointer of access gets pushed onto the stack pointer. Then the instruction pointer is replaced with P, which is our function. Which is our function to what we actually want to do. It's that one is also then being pushed on the stack. Yeah. Push return address for main. I don't know where we end main. Then push the starting address. Like, didn't we just always end main? Which I didn't quite get. But, like, why are we pushing 2 instruction pointers? That's why. Push the start context. Start here is... start, that's just all the yeah, that context, that's just well, let's just destruct all these RSI RDI. Wait, what? What? Huh? That doesn't make sense. Why are we pushing an empty 0 stack pointer? I cannot make sense of this. Okay, good enough. Well, I don't care about this right now and not about this. What is the push function doing? Just it does a pointer. Ooh. Pointer minus size. So it grows it from top to bottom. Which, yes, that's how the stack is supposed to be, but is this one, like, how? Oh god. This is confusing me so hard right now. The thing is, if I have this, if I get this part working at least, I can finally make like other stuff which is not as like other programs that can also run on this thing. Like, currently... What do we return here? By start process we return the process ID, okay. And that has a stack pointer. We do make a new context here, which is a stack pointer on which like a lot of stuff is pushed. But like, I would own like at the moment I don't care about the flags. Like the flags are whatever. Also, do the flags even matter? Because when we do the flags matter in this context here? Because when we switch context, we just give it the new stack pointer. Interrupt handler call switch context, and then we move it from EAX to ESP, and we do proper D. Okay, for that I need to check instructions. Proper D. Pop all general purpose registers. Yeah, so pops double word and word from the stack and the general purpose registers. Flag. The deflag in the current code says that we set. Flags affected none. Yeah. And the same with push D. Yeah, you would have to do push FQ if you wanted, or push F and then nothing, or D or Q to like push more. Push it D is also what? No flags affected. Okay. Well, we... fuck. These flags here, what do they mean in this case? Start process. Oops. I want switch. Switch context. I want that here and start process here. Right, new context. One shifted by 9. Okay. What? It just... that doesn't make much sense. Flags, yeah, not that fits in the register at least, or in what it's doing here. I don't understand the flags. I could probably like tries to put one flag that's important, but I think I can just ignore the flags. Okay, how do I have it here? Naive interrupt Right, I do wanna check that this also just works. It does compile at least. Oh god. But I wanna check again. How does it work that the push instruction works with minus? Because the thing because this pointer push onto this pointer and it just does minus size or like it. This is... Oh wait, here. Okay. Oh god. I don't know why people don't join definition and assignment. Because like here defined and here assigned. Plus memblock. Okay. God. Oopsala. Set a temporal user mapping to fill the page with the context. I don't care about that. Okay, so... Yeah, it just does that and then grows it from top to bottom. Okay, at least that makes sense. Oh god, this is... Like, this is so much thinking and so little coding. Which I kind of hate. So I get new process stack. Okay, that's fine. But yeah, then apparently I may end process here. Have start process and then here the heap I can, yeah, it would just be like a mem set and then all 0. Yeah, but I don't care really about zeroing out the heap right now. Okay. So... Then what I'm gonna do is just gotta figure out, let's just say I do not care about my flags because I don't know the sizes right now and how many flags it does. I could just figure it out, couldn't I? Push FQ, push lower 16-bit of E-flex, oh, I don't know, push E-flex, push R-flex, so it pushes 64-bit R-flex, decrements the stack pointer by 4 if the current operand 32. Oh god, in 64-bit mode, the instruction default operation is to decrement the stack pointer by 8. Okay, I do know now how much it is. Right, but by 8. That's just... Doesn't it just save one flag? Yeah. These are... Because they are just flags. And all the flags are either 0 or 1, so... That's fine. Okay, I can put that back in then. Because that is fine. And how many do I have here? Doesn't it tell me how many lines I've selected? Yeah, 10. No, it just tells me how many chars I've selected. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3. This is everything without RSP, isn't it? I think so. Anyway, NASM 64-bit registers. Give me a cheat sheet. 1, 2, 3, 4, 4. Yeah, that's those ones. Those are 8. I can see that. And then these are 7. 1, 2, 3, 4. Okay, yeah, it's everything without RDX, IDX, RVP, RSI, RDI. Yeah, without RSP. Okay. Okay, yeah. I was wondering why is that the stack pointer not here, but you wouldn't push the stack pointer onto the stack most of the time. So that is fine. That is fine. Okay. I gotta check something. Okay. Right. Process C. I can. No. Process C. Process H. Close that one. Okay. Then I do want context, how I had it earlier. I am just gonna... this one here, kernel, source, was it in process C? No. Was it in schedule C for some reason? No. Was it in, no, not in kernel C. Then in include process H. Nope. Okay, I've deleted that earlier apparently. Oops. Okay. Type def struct context context registers UM64. So R8 R9, R10, R11, R12, R13, R14, R15. I just noticed. Hold on. RDI, RSI, RAX. Wait, now. Macro. Let me actually do it in the order that is gonna be popped or pushed. What order do I do? Popped, because I'm only using context when making a new stack. So R10, R9, R8. Hello, hello, welcome. Hope you're doing well. I'm just doing some programming. RDX, RDC. Wait. RCX, RBX, RAX. That should be all of them. Radeon Linux. Yes, I am on Linux. No, not Gen 2. I am on Fedora with i3 installed. There you go. You can screenshot it. Oh, yeah, I use i3 because it's really nice. And I do not have graphics card drivers, which is really funny. How is... how is my... let me see. Oh yeah, OBS is just chilling with 40% CPU usage. Fedora with Sway, Linux, Sway, let me see. Tiling manager for the i3 when oh, a Wayland. Okay. But it's the workstation one. Workstation you mean with GNOME, I think? I had it at first. At first I was on Fedora GNOME, because I don't like KDE. And then I switched to i3 later on because i3 was like quite nice to use. Because like I just love like it's just so intuitive after like a bit. i3 is so nice. I made a Windows program that did some stuff like that makes it more similar to i3. But yeah. Right, I want process here. Right, I want a new context. Wait. Macros. Okay, now it starts with popping those and only right. The flags are popped at those points. Okay. If I get the order wrong, it's gonna be so annoying. Well, then I just gotta flip it, but I should just be able to flip it better. Yeah, register start. It's gotta be 15 zeros. How many do I have? 1, 2, 3, 4, 5, 6, 11. 12, 13, 14, 15. That's one. I'm new to old Linux stuff, like it's been 2 months since I started using Fedora, so yeah, I'm... Ah, yeah, okay. It's, the thing is, like, with Windows, it is chronic pain. With Linux, it's more growing pain. Using NVIDIA... no. no Vim stuff for me. This editor is called Focus. It's not terminal stuff, it's just a program. It's actually made in Jai, like the programming language from John Blow. And it's basically a text editor with just some syntax highlighting. There's no IDE functionality whatsoever. Oh, good. Oh, good. But yeah, I just like it because you can make this is my own theme, which I just like this theme. It just works really well for me. And you can let my brain catch up. You can customize the theme really well. Okay. Start is being pushed onto the stack. But wait. If start is pushed onto the stack, that means if a process then starts for the first time and we're in switch context, this is our new stack pointer. Then we just we map the heap and stack. And we return this stack pointer. This is, yeah, that is then ESP. We return a stack pointer with all the registers at 0? What? Wait. How is context defined again? Context. It's an empty stack pointer, but wait, there's no EIP. The instruction pointer is right here. We have the instruction pointer. So when we switch context, switch context, we move that here. We pop from that, and we have our instruction pointer. I think. This song's a banger, not gonna lie. Thank you. It's just like YouTube playlist. Like there's a lot of Uma Musume stuff. And just VTuber stuff. Oh, a Minecraft song in between. Oh, there. Oh, Fat Red also in between. Oh, yeah. Oh, there's also ABBA. Oh, yeah. That's just fun music. Let me pop that back there. Okay, so and the rip EIP should then be after these. Wait.
Wait. Why is ESP in there?
That makes no sense. Why did he write it like this? I'm currently trying to learn from this code here and implement it into my own. But I'm failing to understand why he is pushing the stack pointer onto the stack. Unless this isn't a stack pointer and this is actually EIP and it's just labeled wrong. Wait, let me get the NASM 32-bit registers. I can't type. Anyway, so if the EAX, EBX, ECX, EDX, ESI and EDI, ESP and EBP, and those are the general purpose ones, then we aren't doing any segment registers. And RIP is also just, well, RAP is being pushed here. Where are we setting KCS? Uppsala. KCS here, kernel code segment. That's probably where we're getting those from. But the stack isn't even getting that far. Like, they're all on the stack, but only the general purpose ones are being popped from the stack. Why is there so much being pushed to the stack? I do not understand it. Oh, you joined Discord. That's on the side. Welcome, welcome. But yeah. I'm just gonna do how I think I understand it, and then I'll see. Right. My macro is not popping RPI. Would you say this is more difficult to develop than a text editor? Yes. Definitely more difficult than a text editor. A text editor is a breeze compared to this, because we are getting so low level. We get from, like, most programming languages are abstractions to machine code. The thing is, we are getting so low level that even though there are no abstractions, it becomes more abstract in a different sense. Why is this semicolon there? And at the moment I'm trying to understand how this dude is getting the instruction pointer to pop from the stack. Because currently he's just doing switch context and then doing pop. Papa D. Because this is just general purpose registers. This doesn't include the instruction pointer. Which is just... what? Why? What? Hello? Where's the instruction pointer being... I'm honestly not getting it. Because after the pop, the instruction pointer is still on the stack. I'm just gonna ask him. I try switching to Linux once more. How many times does it make it be switching to Linux? How many times have you now switched to Linux? Yeah, 13 times and 8 distros. Oh my god. That is not few. Is Uma Musume good? The story is pretty good. So, in my opinion, so what many people, like, the game is pretty nice. What many people got into it is with Uma Musume Pretty Derby. It is, let me go to any list. Then you must have used most. I think he's used Nyarch at some point. Uma Musume Pretty Derby. So, we have the Uma Musume Pretty Derby TV series, which is like 3 seasons. This season 1, which is like kind of the weakest, like even animation-wise, it's not my style. Sequel, we have season 2, which I heard is pretty good story-wise. And sequel, that's special animation, and season 3, which is oh, it is season 3 the one? Which one? No, season 3 is the one with Kitas and Black, right? Yeah, right, Kitas and Black. That one I heard is a pretty good story. Oh no, season 2 and 3 have some pretty nice story arcs, as far as I've heard. Funny thing is, Nyarch Linux was the only one that worked. Season 2 is honestly the best of Pretty Derby. Okay, yeah. I haven't watched any of the Pretty Derby seasons. What I have watched is... There's also I can actually... What does... Wait, do I have it open here? I do not think I have it open here. Actually on YouTube, which is pretty funny. If you just want to try and get into it. Where's that there? Uma Musume Road to the Top. Tops. This is the official anime, officially uploaded by Psy Games. Road to the Top is, as far as I've heard, also really good. It's basically 3 main characters. Here you have Narita Top Road, Admire Vega, and there, TM Opera O. Those are kind of the 3 main characters. Most of it is centered around Narita Top Road. But yeah. And I've heard the animation is also pretty good. Like, if you look at the faces, like, the faces they do in these animes is... wow. Some of these expressions go crazy. And then Uma Musume. Then there's also a movie, a beginning of a new era. This... yeah, like Psy Games animations, they are cooking. Oh wait, no, is it only 4 episodes? Okay, it seems to only be 4 episodes that are up here. I thought with like 1 or 12 it was all, but I never quite looked at it apparently. But yeah, they're just some promotional stuff apparently. Then there's Uma Musume, Road to the Top. No, fuck, beginning of a new era. That's getting late. I'm gonna have to give it a try now. Oh, it is only 4 episodes. Oh, goddamn. Really? I never knew. But yeah. And beginning of a new era, this is what I've watched first. And it is... oh, such a good story. The animation is phenomenal. And it's lovely. You also have TM Opera O again, but more of a side character. Jungle Pocket is the main character, and Pocket is basically a shonen protagonist, headstrong and just goes at it. But there is also some really there's some amazing character development in this one. Like, it's a movie, like, what's the runtime of it? I can't find it here right now. Runtime. Okay, yeah. 108 minutes. It is definitely worth the watch. I am also loving the OST of this one. Right, yeah. And then lastly, the most recent one, Uma Musume Cinderella Grey. It's about Ogre Cup, and once again, a phenomenal story. It's nearly a 10 out of 10 for me. Like, beginning of a new era is 100% 10 out of 10. And Cinderella Grey, both seasons for me are kind of a 9 out of 10. Very close to being 10 out of 10. So, like, loving it. Great story. Again, amazing animation and lovable characters. Yes, the bullies are just unnecessary because the bullies add nothing to it. Bully plots have been done to death. There are no twists with bully plots anymore. It is overdone and it added nothing to the story. Because at the end, the characters like become her friends, and it's like, why not make them like rivals or friends in the beginning? Like, why make them bullies? It is just, I have such a gripe with it. Oh yeah, this is, this right now is the ending song of that one. B, do you think if I show this one, it's gonna be much of spoilers? I don't think so. Like, I'm just gonna show you this one. It is pretty good, and I don't think you're gonna be spoiled that much from it, really. you're not gonna get, yeah, no. Without context, you won't get much here. And like, this opening is a banger. Like, let me just honestly make it a bit louder. Running crazy spoiler? Oh yeah. We can go like to half of the opening. Like half of the opening, I think it's gonna be. Wait, is it really spoiler? We're gonna go to half the opening. I think that's like, just watch it and see it, and I would say if, when you watch it, you're not gonna see too much of it. They all run, so the thing is, this is such a good opening. And the animation of it is also just really good. I think about here is good. The Kita in the background. But yeah. It is really good. And the thing is, what I showed you just now is like it's some stuff of season 2. I think when you, by the time if you get to season 2, you're gonna have like forgotten it, I think. Because there's also really good stuff in season 1. Prequel here. Season 1 and season 2. They're like each like 12 episodes? No, wait. Part 2 is 10 episodes, part 1 is 13. And there's also, I think, gonna be a part 3. But yeah, I highly recommend it. And if you think you do like the stories and you want to know like more of like each of the characters, the game in that sense is pretty good. The game has lore for every character and like event lore and like just an overall also a lot of story if you want to get into that. The game has that. Like that's how Manhattan Cafe. Like because of the game, Manhattan Cafe also like one of my favorites. Like my favorites go like this: Jungle Pocket because of beginning of a new era, Augury Cup because of Cinderella Grey, and then Manhattan Cafe just because of really good in-game lore. Like just good. Oh, okay. That was a lot of rambling about Uma Musume. Oh, I kind of switched gameplays like some of the VTubers. I like a lot of them, like from what I've seen, a lot of them do just skip through the story. Which like if you just wanna, like I'm also guilty of that. I also am guilty of just skipping through the story and just playing the game because I want to see number go bigger. Because that's also like a fun aspect of the game to just see the numbers increase. Like the numbers that you can reach. Because like each run like can build on top of the next run kind of. Okay. Then let me figure out more of this again. Because if we have a new context, Ixi Uma playthrough and I don't know. Because I don't know how I would make it fun. Right. Are there two different implementations for this? Of course there are. Why are there two implementations for this? I do not know. Well, who knows? Yeah, just schedule out process, get process ID, and set processing queue. And here it, well, it kind of does the same. I still am not sure what to do, what to make of this one. Wait, the music is gone. There it is, there it is. Let me get the music back. This song is called Transforming, and it's Silent Suzuka and Agnes Takion, and Silent Suzuka's voice actress does such a good job. Most stable distro. I would say the one that doesn't start, because it can never crash. Okay, let me... what is this function? Wait, is that... Wait, no, that's... Here it's defined. Yeah. Oh, okay, what? What is this doing? I do not know. Oh. But yeah, I don't think I can figure out what the heck how the heck this is working with like I asked the guy, I'm gonna see if he answers. I switched from Ubuntu just cause I felt like it. I do use Fedora, so... But I did have a crash earlier, where just everything crashed. I could only move the cursor and nothing else was working anymore. But yeah. What else can I try right now? Okay. I think right now I'm not gonna try anything. I'm just gonna... Why is toolchain in here? Let me config, project config, ignore, toolchain. Does it now still show the toolchain? Nope. Fuck, that's nice. Oh, right, because it's not main, it's kernel. Right. It's kernel C. Yeah, so here I started two processes and then switch them in a while loop. Just gonna make some notes real quick for Naive interrupt. That one is still looking as it's supposed to. Help. Loaded this one. Does heap init is also here. Sys var 0 right now. Oh, there. I think I can at least show the. Oh yeah. Wait. Got it. Oh, I accidentally deleted that part. Oh, there. As you can see, typing works. Like I can even do spaces. I can. Good. I can even hold a backspace down. And when getting to the end of a line, it also wraps. I can press enter, go to a new line. The funny thing is, I'm pressing backspace right now. It doesn't know new line stuff. I still have to do that. And currently, as you can see, yeah, some characters do not work as intended. The numpad works. Oh, that works, but why does plus not work? Okay, this plus works. Where's minus? Okay, I don't know. Oh yeah. What I can also show is sysvar. Oh, I went to Hiroshima and see something new. Yeah, that was just I can do text and stuff. I can also do this if I now start. You see a lot of numbers. What this is a list of all supported resolutions. The resolutions that are interesting to us are all the ones that have an X32 at the end. That means they are 8-bit colors over an ARGB. ARGB is alpha, red, green, blue. Alpha is transparency, though it does nothing really. And with arrow keys up and down, you can select the mode. So we can, for example, select mode 0. And yes. Kernel. This is actually not a rainbow function. It's but yeah. We can start again. 0 and yeah. The thing is, it's not quite easy to show. There. You know, this is kinda scaring me. I don't know much about the stuff, even though I'm trying to get into software. Okay. I am in university for this stuff, so. There. Right. Zoom to fit. So yeah, as you can see, this is. Oop, that is big. Sorry. I just wanted to get the cursor back. But yeah, this is 320 by 480, I believe it was. Now, 320 by 200. We can also do other resolutions, like let's do 800 by 600. Get this smaller, yeah. As you can see, it's now 800 by 600, and also the colors now are slower because it has more pixels to set the colors of. Yeah. As for the question, did I write this myself? Partially. What we have here is, as you can see, the kernel. The files in the kernel, I wrote those mostly myself, besides some stuff that I like took inspiration from here. Like quite a bit of inspiration from here, and if we, for example, go into naive console, a lot of the stuff here, like the print binary hex decimal, or like, I did not write those. Like this function I didn't write because it was already there. But yeah, what I wrote is like backspace, enter, space, stuff like this stuff I kind of rewrote to make it work. And like also added some stuff, but yeah. And then we have everything in the bootloader. The bootloader, except for some stuff, is all stuff that was already there. The bootloader basically sets up your CPU, because a CPU starts in 16-bit mode. You have to go through several steps to basically enable 64-bit mode. But yeah. Here's that some stuff. Yeah, here. The graphics setup. The graphics setup in the beginning was very simple. I just set one graphics mode, and so I basically wrote a lot of stuff here to make it work. Can get rid of this now. But yeah. I wrote a lot of stuff like as just straight assembly to be able to select modes, as you saw earlier. But, it's pretty fun. Like, for me, I like assembly. But yeah. Then we have pure 64 ASM, yeah. Here, for example, as you can see, it starts in U16, that means 16-bit mode. And it starts at this address. And basically it goes through like all kinds of things. Here it includes this file where it's instructions in there. And just does a lot of stuff to like basically initialize the CPU. Assembly is fun. Like, assembly is fun. Really. That's not scary. Like here we are then in 32-bit mode. Yeah, and just several steps, and then here we are already in 64-bit mode. Like, this file is like 600 lines of assembly. With all the other files, there's not over 2,000 lines of assembly. It's just like, yeah, fine. And yeah, and then it goes from here to jumps to this address, which is then starts here, which is loader. Oh, there. It's not scary. The ominous sub CX1. Huh? That is, you subtract 1 from the CX register. That's all it is. Like, this one is more weird, like JRCXZ. If you don't know what it is, the thing is, if you've done a bit of assembly, you can easily read this instruction. J stands for jump. RCX stands for RCX. RCX is a 64-bit register. CX is the 16-bit register, and ECX is the 32-bit register, and Z stands for 0. So this means jump if RCX is 0, and then this is the label where to jump to. So, and if RCX is 0, what we can check here, because here I put config VESA into RCX just before I jump to here, which means config VESA is basically it's a byte. Define byte, this is how you like declare variables in like immutable variables. And it's just like, do we have a graphics mode or are we in text mode? That's all that part is. And I just put that into RCX and put it here. Because the reason is the bootloader and my kernel, they cannot talk to each other. They are like two separate programs, kind of. First the bootloader runs and afterwards the kernel takes over. So I cannot just check config VESA anymore. I have to put it into a register and then I can check it. Which is a bit annoying. But yeah, that's a problem for later. Like I can just put it here and then it's fine. I do the same with VESA mode info block buffer. Which is a mouthful. But this is basically which graphics mode I currently have. Like the resolution and everything kind of. I put it in there and then I save it here. Like VESA mode info block mode info. And where do we have it? We have this here. And then I basically like get like just some variables that I need, like the screen width, the screen height, the bits per pixel, the pitch and the frame buffer. Frame buffer is where in memory, like where the memory is stored for the thing. And here VB info mode, we can take a look here. This is this thing. Most of the stuff you do not need to know. Oh yeah. I'm just gonna delete this because that is now... Where is that defined here? I don't care. Oh yeah. There are... It's quite fun assembly. Can we connect bootloader and kernel? Theoretically yes. We could just make it into one program. We could just have the bootloader and kernel like in one program. But the way, because I didn't set up the project itself, the project was already set up like this and I don't want to mess with that at the moment. Because if I wanted to mess with that, I would need to do this. That is that make file in the bootloader, which is... Because this also comes with BMFS, which is called bare metal file system. So it comes with a file system, which I am not using right now. Right there. And then make file would be this one. Yeah, so we do all this stuff. We assemble all of this. And what we then also do is build. We do all of this. So yeah, I don't want to touch this too much. This is basically all kinds of stuff like just so we can make the code run on our like actual hardware. Like this code, like everything I've shown, like this can run on actual hardware, not just in an emulator. Because like right now here QEMU, it's running in an emulator. Like this is the actual resolution of it. A bit small. Let's go to... Oh, no, too high already. Oh no, we want 16, okay, well, whatever. Yeah. Like this is just running in QEMU, which is just an emulator basically. But yeah. Let me clean up a bit again. Wait, no, I wanna go to sys var. Disable this again, and with just that we are back into text mode. Currently I can only type in lowercase because shift is not enabled. Shift doesn't do anything. I understand a little bit better now. Okay. But yeah. What else? Right. Naive keyboard. This one is fun. Do you see all this? Do you see all this? I worked it all by hand. It was fun. But yeah, this is basically LUT means lookup table. And everything here corresponds to scan codes. Bitrate killer. But yeah, everything here corresponds to a scan code, which means when you press a key, your keyboard sends a scan code to your computer. And those are here a hex FDF 255 0255. I'm gonna have dreams of this now. And there, for example, scan code 57 is my spacebar, and I assign this to the 20 in hex, which is 32 actually. But yeah. Or here, for example, the enter key, I assign it A, which is 10. That's just the basic Unicode definition of it. But yeah. And I also have here, like, for my shift keys, like for all the shift keys, I have stuff. Though at the moment not implemented, because I would need actual text, like actual rendering, like text rendering. Because the text mode only has a specific amount of things that it can show. And then Alt GR, which is a key that you only find on a German keyboard. A German keyboard. To like write the euro symbol, for example, and stuff like that. But yeah, like all these symbols. And then release scan codes. Also for the numpad. Oh, right, here's also the numpad. I don't know why the... Oh, because plus an A... I haven't... Oh. It's also an ESP keyboards. Okay, interesting. And then down here, there's a fun thing called extended keys. They have a scan code, like this one. And then they have an extended notification in front of it saying, hey, we didn't have enough scan codes anymore, so we needed to put something in front of it. And then we have double extended, which is even more fun, because now you have several bytes that come first, that you first have to check. Oh, is this an extended? Or wait, is this a double extended? Which, like, for some reason, some keyboards, like the arrow keys, can be double extended instead of just normal arrow keys. Because if we go up here, no, that's... I thought that's where the arrow keys were. Arrow. Okay. Apparently arrow keys are not set anymore. Oh, right. I did it with BIOS interrupts. All of this is not good for my head. My last brain cells are dying. Okay. And this is then the keyboard interrupt. Like the actual thing that... So here, if interrupts are basically... you have interrupts on a computer for anything like external. So like, say for your mouse, for your keyboard, for the timer that is next to a CPU, like this timer, the programmable interrupt timer, like your keyboard, as I said, or like any USB device, or a hard drive, for example. All those have interrupts, so they can send messages to the CPU saying, hey, this is done, or hey, I have something new for you. So what you do here then is you call the keyboard interrupt. Then you need to import from port 60 a byte. This is your scan code. And then I have a circular buffer, which I might have to explain with an image. Circular buffer. GIF. Yeah. I don't know how well this is gonna explain it, but you have a buffer, in this case 12 characters here. And you have I cannot stop the thing, so you have a read pointer and a write pointer. A write pointer is, so first you read in things. So here I'm putting things at the, I'm putting the write pointer one next, and then at the head I'm putting the scan code, and then the head is next. You know what? No, I'm not gonna explain it. I'm not gonna try to explain it. This is... A circular buffer is easy to understand if you know what it is. Otherwise, sorry, I cannot explain it. It's basically a circular array, if you know what an array is in programming. But yeah. I do the keyboard interrupt. The only thing I do is I collect the scan code. So what I do is I collect the scan code into a buffer. That's what it is. Then I return. Then I do this. I move 20 in hex into AL, and then I output AL into port 20. So that just means, hey CPU, I acknowledge the interrupt, and then it goes back. Then there's also like the PIT, as I said, the programmable interrupt timer. And we have the PIT IRQ here. Another thing I did not write myself, because this thing was just, nah. I just copied, like I straight up copied it. I just straight up copied this thing. What I can show you is something interesting. If we run it, these are the ticks of the CPU counters. This is how fast the CPU, how fast the timer is of the CPU. Right there. This is like a pretty neat visualization. Right there. Also, for the keyboard, we're actually not done. We can go to the kernel, and here we have a function called build key event. If we go here, what we have here is build key event, and here we just read from our circular buffer, we take it, and we just put it into C. Then, what we do is we use a lookup table. We see, okay, for example, I pressed A on the keyboard. We have our scan code is 30. What we want is we want to report back 61. And then, yeah, we have 61 now here. So as long as this isn't 0, we put whatever is in our lookup table at C into our key. And yeah, and if it's a release event, then we do that. And then we just say, okay, go to the next event. And then here, key event is a global struct. Every file can access it. And if our key is not a 0, which means no key was pressed or a key was released, then we can say, okay, make it do this thing. We basically cast it to a const char pointer, which is fun. Oh no, we cast the address of the key to a const char pointer. Then we print it, and then we just set the key to 0. So our next build key event can then put a new key in it. Leave console. If we go here, actually also have this instead of drawing, we're going to NC rainbow. Leave console h void NC rainbow. Wait, is that actually NC underscore rainbow? We'll just call that. Right. And here. Okay, and if I'm not mistaken, we don't want to say NC rainbow. Missed. Okay, should be an easy fix. Because here I have video. What was it? Line 121 video size. I renamed it at some point. Video max, I think. Yeah. Video max. Yeah. And nothing happens. Is Vesam sys var? No, Vesa mode is off. Okay, naive. Console C. Wait, what did it say? Okay, no, it's all text there is just normal. That is interesting. Alright, it doesn't NC clear. Let's just comment that out, and it still doesn't NC. Oh, I think I know what's happening. Okay, let's... Right now. Oh god, this is... I don't fully know anymore how this works. Damn it. Because we have the color and J modulo this. Wait, no, this is 1, 2, 3, 4. 1, 2, 3, 4. No, that's just okay. J should be the character. J++, and it should just always. Also, while one, yeah. FK. Oh. Sure, let me, so we have this. K is not used anymore. No. Okay, whatever. I don't know what's going on. I think I'm just gonna leave it this for the day. I'm closer to the thing I actually wanted to do, but still not quite there. I still gotta figure some stuff out. How the frick do I continue? How do I the instruction pointer from the stack? Okay. Yeah. I should eat something, I think, and then just sleep. It is 1 in the morning. As you can probably see here. Yeah. I hope you all have a good one, and thank you so much for joining. And I will see you... I don't know when, honestly. I stream so randomly. Bye.